Hi everyone, how are you doing? Okay, so I hope my audio and video everything is fine. So let's get started with AIMT4 solutions. Okay, so let me know if that is fine. Okay, is my audio clear to everyone? Okay, great. So let's get started. So before I start, just a quick thing that I would like to thank everyone who has attempted this AIMT4. So in AIMT4, there were 4,134 students. Like there were two unsubmitted attempts. So if I count them, then 1,136 students, right? In AIMT3, it was so it was 4,136 and it is 4,257. And in AIMT2, it was 4,033. In AIMT1, it was 3,750, right? Okay. So you all know about it. Now let's just get started. So I would like to thank everyone for participating in this AMT. And in this session, we will see the detailed solution of all the questions which are related to my subjects. Okay. Yes, I'm good. I hope you all are also good. So let's see this question. In this question, they are saying that to transfer a web page of 9 objects, a non-persistent HTTP takes 18 RTT. So if you know the non-persistent HTTP, right? So it is basically in the way it behaves is basically like this. Let me write it. Non-persistent. Okay. The way it behaves is something like this. Just a second. Okay. So basically, non-persistent. What happens that whenever you are sending some request, for every time you have to establish the connection. Okay. So for every so you can say for every object we have to establish establish TCP connection. Okay. Which means if they are saying that 18 RTTs you are taking for 9 objects, which means 2 RTT per object, which means out of this 2 RTT, 1 RTT you are taking for the connection establishment and 1 RTT you are taking for the actual data transfer. Okay, so you can say 1 RTT it is for TCP connection and another 1 RTT is for the data transfer because it was non-persistent. Okay, so that's why I'm taking 1 RTT for each object. But if it is persistent, okay, in case of persistent, what happens? Let me tell you. See, it was non-persistent case, but now suppose if it is persistent, okay. So suppose persistent HTTP. In this case, you will establish the connection only once. Okay. So you will establish TCP connection only once. Okay. Now it comes in two flavor. This persistent HTTP comes in two flavor. One of them is called pipeline, and another one is called non-pipeline. Okay, non-pipeline and pipeline. Now, generally, if they do not mention anything, then we need to assume it is non-pipeline. Otherwise, they will mention. Okay, in non-pipeline way, what happens? Since you just have to establish the connection only once in both the cases, so in non-pipeline way, you will say that first you have to establish the connection. Okay, so let's suppose there's a three-way handshake, and in this, okay, in this last ACK, you can also request. Okay, request for the data for data. Okay, so basically this is you can say 1 RTT you are taking for the connection establishment. Okay, and then if it is non-pipeline, then you will be basically you will be requesting for one thing, you will be receiving that thing, you will be requesting for other thing, you will be receiving that thing. So you will be keep on requesting, keep on receiving. Okay, this is called non-pipeline way. In non-pipeline way, basically you you keep on request and keep on get, which means one RTT for the connection establishment. And now this is three-way handshake, which is one RTT it will take. I mean, it will take more than one RTT, obviously, but the last ACK will contain the request. So basically, it will be used for the data transfer. I mean, this time we can use for the in count of the data transfer. Okay. So basically, you will be keep on requesting. This will be request for some data. Let's suppose the base page, okay, and then you will be getting it. Then you will request for other thing. You will be getting it. Then you will be requesting for other thing. Then you will be getting it. It is called non-pipeline way. Okay, so it is called non-pipeline way. In the pipeline way, what you will do, you will request. Okay, so see, until and unless you get the base HTML page, you do not know how many objects are there. So obviously, one RTT for the connection establishment. Okay, so this is for the connection establishment, and then you will be having one more RTT for the base page. Okay, this is, you can say, for the base page, and then you will have just one more RTT, okay, for all the pages. I mean, all remaining page request you can do at once. All remaining page request, okay, at once. You can do all remaining page request at once. So which means here one more RTT you will be needing. This is called pipeline way. Okay. So basically here generally you take just the three RTTs. Okay, if the data is very short, which means you can transfer, let's suppose, in one RTT, then it will take just three RTT. But here it was asked for the non-pipeline way, which means one RTT for the connection establishment, and then there are nine objects, right? For every object you will be taking one RTT. Okay, so nine more RTTs. Hence the answer is 10. Okay, hence the answer will be 10. Okay. Is this okay to everyone? Hence the answer will be 10. So basically for the nine objects, you will say that one RTT for the connection establishment plus nine more RTTs. Okay. So 10 RTT. Okay. One RTT for the connection setup and one RTT for the first object and eight more RTTs, or you can say the nine more RTTs, right? Now let's see this question. So in this question, they're asking that suppose you are sending some packet and or some data you are sending. So basically they're asking that for this particular time, like basically they're saying that communication link has some bandwidth and one way propagation delay is given. Okay, data is transmitted in fixed length segments. Each of length is given as 1000 bits, right? Each of is 1000 bits. Assume that ACK is negligible, which is fine. For a single segment transmission, consider the time interval starting from the moment the segment begins the transmission. So basically, they are saying you consider the moment from where segment begins the transmission. Okay, so this is basically the transmission time, and this is the propagation time, right? So and this is the ACK receive time. So this is called RTT. This whole thing is called RTT. I mean, there are like various definitions of RTT. At some places, they only say that okay, this is RTT, which means the propagation two into propagation time is RTT. At some places, they say that this whole thing is RTT. I mean, here in this question, it is not needed to know the definition of RTT, but yes, like just to solve the question, I'm saying that this is RTT, okay, which is basically TP plus 2 TP. TT means transmission time plus 2 TP means propagation time. Okay, so this is your whole time. They are asking for this particular time. They are saying that uh, that consider the time interval starting from the moment the segment begins the transmission till you get the ACK, until you get the corresponding ACK. What is the maximum number of data segments that can be in transit outstanding but not yet acknowledged during this interval? So basically they are saying during this interval. They are not asking okay, they are not asking at the end of this interval. See, for this interval we will be taking RTT will be TT plus 2 TP, which means TT is basically length upon bandwidth, and if you find out TT, you will be finding this, and 2 TP is this, so RTT is this, right? In this time, you can send 25 packets. So basically, this is 500 milliseconds, right? So which means, see here that you are transmitting some packet, and then you will be receiving the acknowledgement at the at the 500th millisecond. Okay, at the 500th millisecond, you will be receiving the acknowledgement. But the question is saying that during this, okay, during this interval, so during this interval, you can send 25 packets, right? You can send 25 packets, and at exact 500 millisecond you will be getting the ACK, but they are asking during this interval. So so actually this particular during this interval, because of that some students got confused. And by the way, I've taken this question from NPTEL assignment, and there also they have given 25 as the correct answer. But some people are arguing that since we have already got one ACK, so 24 should be the correct answer. So just to avoid the confusion for the future, I'm basically just defining the interval. Okay, I'm saying the strictly less than this RTT. Okay, just for the future, I modified this question so that there is no confusion. Okay, for now we are keeping 25 as answer. So we are saying during this interval means that you are transmitting and then you are getting the ACK. But during this whole interval, okay, the maximum could be during this whole interval, the maximum number of the packets, right, that could be outstanding are basically 25. Okay, so they are saying maximum number of packets. See, the question is not wrong. I mean, there is nothing wrong with this question, because they are saying maximum number of data segments, right? So maximum could be 25. Yes, there could be 24, but that is after this interval. Like, but the maximum you have got the 25, right? Okay. So maximum, there will be 25, because they are asking for the maximum number of data segments, right? I hope that is fine to everyone. Okay. Now let's see this question. So this question was related to operating systems paging. So here they are saying that the page table is given for some process. Let's suppose P1. Okay. So page number 0 is basically mapped to this frame. Okay. So page table means that it will tell you that page number 0 is mapping to which frame, page number 1 is mapping to which frame, and so on. Now they are saying we consider two virtual addresses. Okay. Two virtual addresses giving two different sizes may be used. So here two different sizes of pages may be used, right? So which means page size 2 power 8 and page size 2 power 12, they are using 2 power 8 and 2 power 12 page size. Now they are saying that assume that virtual address whose page number does not appear in the table has no valid translation, which means that if the page number is 2, the frame number is this, page number is 3, then frame number is this, and so on. If the page number is not present in this page table, okay, the given page table, then you assume that there is no valid translation. Okay, now select all the correct statements. So basically the statements are under page size 256, the virtual address this has no valid translation, and so on. Okay, under page size 256, they're asking for these two virtual addresses. So what we need to do, if this is page size, which means 2 power 8, right? So first let's just divide this into two parts. This 2 power, using this 2 power 8, let's just divide this into two parts. So it is basically 1004, right? This is the virtual address. 2 power 8 means this, right? This will be your offset, and this will be your page number, right? This is your page number. Just check whether this page number 0, 10, page number 10, which means like in hexadecimal page number 10 will be how much it will be. It will be 10 means 4. I mean, here in the hexadecimal this is like 4 binary. Okay, and then this is 1, right? 1 and then 3 more zeros. So this is 2 power 4. 2 power 4 means 16. So basically this is page number 16. Let's just see if page number 16 has valid translation or not. Since we are given till page number 8, so page number 16 has no valid translation. So that's why you will say that yes, this is true, right? There is no valid translation for this. What about this? For this, the page number will be 0, right? Page number 0 has a valid translation, okay, which is uh, 8D10, okay, which is 8D10. So yes, so I will be having 2 because this is offset, and then 8D10, okay. Is this fine to everyone? So basically, this is also correct. Similarly, C and D are also correct in this. Okay. So if you have page number and offset, so you will see that for this page number is 16, and page number 16 has no valid translation. For this, the page number 0, so you will just replace this page number with the frame number, and you will get this as valid translation. Now, if the page size is 2 power 12, in that case you will be having 3 hex. Okay, instead of 2 hex, you will be having 3 hex. So which means here the page number becomes 1, and so it is valid translation. Here also it is valid translation. Okay, so all of the statements are correct here. All of the statements are correct here. So one of the student is saying that in in one of the gate year actually it happened that they've actually mentioned, okay, they mentioned in the you can say description of, before we start the gate paper, there are some instructions, right? In the instructions they mentioned that no MSQ question has all the options correct. Okay. So I think in gate 2024 it happened, 24 years. I think in 2024 it happened, and it was carried for 25 also. But it is not necessary. I mean, you must be reading the instructions. It may be possible that in the instruction they are writing that okay, not all the MSQ in the MSQ not all the options are correct. In that case, if for you all the options are correct, then you might be making some mistake. Okay. But if they're not writing such things, then it means it is possible that all the options could also be correct. Okay. So here in this case, all the options are correct. Now let's see this question what they're saying. Consider a system in which jobs A, B, and C arrive for the CPU scheduling starting at time 0. Job A arrive at time equal to 0 and requires 10 seconds of CPU time. Okay. So basically, A is arriving at 0 time, right? At t equal to 0, A is arriving. And then B arrives immediately after job A and requires 15 seconds of CPU time. And C arrives immediately after job B and requires 10 milliseconds, 10 seconds of CPU time. Okay. So their CPU times are given, and arrival order is basically A, and then B is arriving, and then C is arriving. Assume that CPU uses a round robin scheduling policy with the following conditions. The time slice is unknown, but it is guaranteed to be less than or equal to 2 seconds. So they are saying that in round robin you do not know the quanta here. Okay, currently you do not know the quanta, but it is guaranteed to be less than or equal to 2 seconds. That's what they are saying, right? See, there are three jobs A, B, and C. A is having time of 10, B is having time of 15, and C is having time of 10. Okay, there is no cost of context switching. If one job arrives just before another, it is placed ahead of later job in the ready queue. Okay, so basically it is a normal implementation. What they're asking is that under these assumptions, at what time job B finishes the execution? See, they are saying 10, 15, and 10. These are the times, right? 10, 15, and 10. So you do not know the quanta. Okay, but one thing is for sure that quanta is less than 2. See, if quanta is even 10, okay, if quanta is, let's suppose, even 5, okay, 5 or 10, whatever, right? Let's suppose quanta is 10, then A will finish first, and then B will run for 10, right? And then C will finish completely because they are having the 10 seconds of execution time, and then we will be finishing and we will be taking 5 more, right? So even if the time count is 10, then also we will be finishing at the last, which is basically, if you just add it, this is 10 plus 10 20 plus 10 30 and 35. So we will be finishing at 35. Even if the quanta is 10. So if even if the quanta is 2, you don't it doesn't matter. Basically what will happen, A will be running for 2, and then B will be running, then C will be running, then A will be running for 2, then B will be running, then C will be running. But ultimately B has to finish at the end. Okay, B cannot finish, see, in any of the case B cannot finish before 35. If if uh, if it is if the quanta is less than 15, then I don't think that B can finish before 35. Even the quanta is, let's suppose, 12. Okay, even the quanta is 12, that A is running for 10 seconds, and since there is the A has finished, then B will start running, right? And then B can run for 12 at most, but ultimately it will be running 3 at last, but ultimately it will be finishing at 35, right? So we will be finishing at the end only. We will be finishing at the end. Even the quanta is 2, even the quanta is 3, it doesn't matter, the B will be finishing at the 10 at the end, right? So which means we will be finishing at 35. Understood? Okay. So I hope that is fine. So there is one comment about the definition of RTT here. Okay, see, definition of RTT doesn't matter. Like, we are not using the definition of RTT. It is defining the whole interval completely. It is saying that consider the interval starting from the moment the segment begins the transmission until corresponding ACK of that segment get back. So basically they're completely defining that interval. Okay, there is no ambiguity in this question, they're defining this interval completely. And then they're asking maximum number of data segments that could be in the transit. So maximum there could be, you can say, 25 packets, right? Okay. So here the answer is 35. Now let's see this question. It was interesting question. I mean, it was easy question only, but interesting in the sense because of the nature of the question. So let's just see what this question is saying. See here in this question we are saying that there is a farmer that must take loin, rabbit, and cabbage across the river. So there is one river, okay, and then the river is flowing maybe, okay. So the farmer is standing here and he must take loin, rabbit, and cabbage across this river, okay. Now, if the farmer is not present on the side of the river, then loin and rabbit, if they are left alone, then loin will eat rabbit. So basically, the rabbit is eaten. If if rabbit and cabbage are left alone, then cabbage is eaten. Okay. So in C program, variables loin, rabbit, and cabbage are basically one. If the item on the other side without the farmer are zero, if they are not with the farmer, the variable shape should be set to one if nothing gets eaten, otherwise zero, right? So basically, they are saying that which of the following C code is correct. They're asking this, that which of the following C code is correct, which means we want to set safe to be one, right? We want to set safe to be one. So let's just check the options. If loin and rabbit, I mean loin is left alone and rabbit is left with the left alone. Basically, loin and rabbit left alone. Okay, so basically, I mean in that case it will be 1 1. Okay, if they are 1 1, or cabbage and rabbit left alone. Okay, in that case it will be 1 1. Then safe is zero, otherwise safe is one. So I think this is true, right? If loin and rabbit left together or rabbit and cabbage left together, then safe is zero, otherwise safe is one. Okay, which means that loin will eat rabbit in that case, or rabbit will eat cabbage in that case. So that's why safe is zero, right? If loin is left alone or rabbit is left alone along with the cabbage, then safe is zero. No, loin and cabbage doesn't make any sense, right? So basically, in that case, they are saying safe is zero. So that's wrong. Loin and if loin is left alone and along with the loin, rabbit or cabbage. See, this is almost same as the previous one, so it also doesn't make any sense. So that's why this is wrong. Either loin left alone, rabbit or cabbage, they does not left alone, something like this. So basically, safe is 1 or 0. So basically, this is also wrong, right? I mean, there should be the combination of loin, rabbit, and cabbage. So the correct answer is A, and it was a good question. Good question in the sense, cute question, I can say. Okay, it was a cute question. So here A is the correct answer, right? A is the correct answer. Now let's just see the next question. Yeah, it was a good question. So let's see this question, what they're saying. It was again C programming related question. So they're saying that suppose there's a function POW x comma y which returns x power y, which means this is basically as good as saying 2 power x. Okay. What is the value of I after execution of the program segment? So what this is doing, this is basically raising 2 power. Okay, this is keep on raising the 2 power, 2 power x, and then whatever x is getting, it is keep on raising the 2 power. I just one counter here. Okay, I just I plus plus. Okay, I is not playing much role. So let's first see that how x is behaving. So initially x is 1. Okay, initially this is initial, and then x will be basically 2 power 1, and then x will be 2 power 1. In that case, I will be becoming 2. Okay, I will be becoming 2. Let me write the values of I also. Okay, so this is x and this is I. In that case, I will be becoming 2, and then x is 2. Now in the next iteration, this will be 2 power 2, right? So x will be 2 power 2, which means 4. Okay, I will just increment. Now in the next iteration, it will be 2 power 4. I mean, whatever is the old value, the 2 power that value, right? 2 power that value, because 2 power x. So 2 power 4, it is 16. I will be 4. Now in the next iteration, it is 2 power 16, the old value, right? So it is a very big number, 65536, which is 2 power 16. So I value will be 5. But the moment it is 2 power 16, at that moment, okay, I value will be 5, but it will not get inside in the while loop again. So basically, ultimately, I value will be 5. Okay, value of I will be 5. So that's why 5 is the correct answer here. Now let's see this. What are the following function return? Assume n is greater than 0. So basically they are just asking for this function, what is it is returning. Now first thing you notice here is that function is running from I equal to 1 to I equal to n minus 1. So function is running from I equal to 1 to n minus 1, right? Now in every iteration what we are doing, we are basically doing s equal to s plus s is initially basically whatever it is a0, right? S is initially a0. So a0 plus I value will be 1 for the first iteration, right? A0 plus A1 minus A0. So basically in the first iteration, if I is 1, then A1 is remaining, right? A1 is remaining. If I is 1, then A1 is remaining. The moment I is 2, which means S equal to it will be. So A1 is remaining. So old value of S, which is A1, plus I value is 2, A2 minus A1, right? Now A2 is remaining. Okay, because this is getting cancelled out. So A2 is remaining. So if I equal to 2, A2 is remaining. Now similarly, you can keep on doing. So if I equal to n minus 1, then A of n minus 1 will remain. Okay, A of n minus 1 will remain. So that's why this is the correct answer. Understood? Now let's see this question. It was related to algorithms, Dijkstra question. So basically they are saying that in Dijkstra algorithm, let's just define some C, X, Y between be the cost between the nodes X and Y. Okay. So between the nodes X and Y, the cost is C, CXY. DV represents the current value of the cost of the path from the source to the destination V. Okay, so basically we are maintaining one vector which is D. Let me represent with the capital or small d, doesn't matter. So basically dx will represent the current value of the distance from the source to x, right? And dy will represent the current value of the distance from source to y. Okay, and then they are saying PB with the predecessor node along with the path from source to B. So for any, just like for example, for y, like py will be, let's suppose if we are coming from x, then py will be x if we are coming from x. Okay, and as be the set of nodes whose least cost path is definitely known, which means these are the final nodes, you can say. Okay, so now they are saying suppose we have y belongs to and s, which means distance to y is final. Now they are saying distance to y is final, distance to y is known and final. Okay, then dz means the current distance to the z is, let's suppose, 10. Okay, so now they're introducing one more, which is z. So they are saying current distance, let's suppose there is some z. Now current distance to the z is given as 10, and we are coming from y. This is for sure that we are coming from y to this z. Okay, and this cost is 3. Then what is the value of the current distance of this? What could have been the value of this? So what do you think? See, if we are coming from this and this value is 10, then this value must have been 7, right? This value must have been 7. Then only we are keeping the current distance this to be 10, right? Okay. Because see, they are saying that I mean cost till this y, okay, the cost till this y is already known. So basically y is final. This is final, right? Now we are relaxing. This is final, and now we are relaxing. If we are relaxing and this is coming out to be 10, then this must have been 7, right? This must have been 7. So in this case, the distance to y is final also, and this is 7 also. Understood? So that's easy question, but yes, this was bit of notation, so that's why this question might seem tough. But they are saying that this is basically the final cost is known, or final distance is known for y. Okay, final shortest distance for y is known, and current distance to z is current distance to z is 10, and it is also known that this current distance we are taking from y. I mean, it is known that p of z is y. Okay, predecessor of z is y, which means we are coming from y. It is also known. This is final. It is known. Okay, this is also known that we are coming to z through the y, and now we are having this 10. This is 3. Then this must have been 7, right? This must have been 7. Okay, so 7 is the correct answer, which means C is the correct answer here. Okay. Now let's just see this question. This question was a little interesting. Interesting for the reason that we have the edge weights, which could be from, which could be even negative weights basically. I mean, it could be a real number. Okay. So consider the following two statements. They are saying that, let's suppose you are having some weights and then you are squaring those weights. Then will the MST change? Will the shortest path change? This is the question. Okay. So actually the answer is that yes, both will change, and that's why this is. I mean, it remain the same. So this is also false. This is also false. Shortest path will also not remain same, and the MST will also not remain same. See here that if you are having this, okay, if you are having this, and then if you are squaring, then suddenly what was what was very less, okay, which is -5, suddenly after the square it is very high. Okay, so MST will directly ignore this. So before squaring the MST is this, but after squaring this 25 is not taken because it is suddenly too high. Okay, it is suddenly too high. That's why this 25 is not taken. Understood? So see, since all the weights could be the negative also, okay, as weights could be the negative also. That's why it is the case. But let's suppose that weights cannot be negative. In that case, the MST will not change. Okay, see, if weights are not negative, if all weights are greater than or equal to 0, then MST will not change after squaring. Okay, which means if some weight, let's suppose a was earlier greater than b, then even after squaring, okay, even after squaring, a square is greater than b square. Okay, if a and b both are greater than 0. Okay, if a b are greater than or equal to 0. Okay, then in that case squaring will preserve this property. But let's suppose if that is the case, if 2 is greater than -5, then after squaring is 4 greater than 25? Then answer is no. I mean, after squaring, this is wrong, right? This is wrong. So if the edge weights are negative, then there is a problem, okay, in MST. But if edge weights are not negative, then this S1 is true. What about S2? S2 is saying that you have the shortest path. Okay, after the square. See, after the square, it is possible that, see, this is 3, 4, 6. So before the square, this 6 was minimum. But after the square, this is 9 and 16, which means this whole thing is 25. Okay, and this is 36. This is 36. Okay, so obviously now after the square, this 25 is minimum, but earlier the 6 was minimum. So shortest path could also change. Okay, so shortest path could also change. See, for the case of shortest path, in most of the time shortest path changes if we are, just if we are squaring, or if we are adding some constant weight. But if we are just multiplying, okay, in that case shortest path won't change, because shortest path depends on the total cost, right? If you're multiplying, let's suppose it's a c, okay, then earlier, let's suppose a plus b was greater than, let's suppose, some weight. Okay, let's suppose you're multiplying with a k. Okay, So let's suppose a plus b was greater than c earlier. Then even after multiplying everything with the k, then k will get common and then k will get cancelled out. I mean, after multiplying, if you're multiplying obviously with the positive weight, then shortest path will not change. But in case of square, shortest path is getting changed. Okay. In case of a square, shortest path is getting changed. So that's why S1, S2 both are false. Okay. Now let's see this question. So in this question, they are saying consider the following characters with their frequency. Okay, so these characters are given, and then they are just asking the valid Huffman code for E. Okay, what are the possible valid Huffman code for E? Now in Huffman, what is the idea behind the Huffman? You just say that you add whatever is the minimum frequency first. Okay, so this G and B are the minimum frequency. You just add G and B and it will give you 3, right? And then b is out, g is out, then 3. Basically you can just add e now. Okay, just add e and it will give you 6, something like this, right? And then you keep on doing it. Okay, then you will be getting after gb you can add e and then you will be getting this tree. Okay, so you can have on the left, you can have 0 or 1, doesn't matter. So let's suppose 0 1 0 1, I'm having something like this. So for the E, the answer, one of the answer possible is 0001. Okay, one of the answer possible is this. Now some of the people, okay, for this particular question, some of the people has commented and then they are saying something which is, very, very strange. So let me tell you one of the misconceptions just that I got to know. See, here, let's just first make the tree quickly. So minimum is G and B are the minimum initially. So you can say B and G you can just have. So G and B. So it G is 1, B is 2. So ultimately it is 3, right? Okay. And then you have for the 3, then you have E. So you can basically have E also. E is also 3. So you can have 6 here. Okay. And E is okay. And then you can have basically this is done. Then you can have A, right? So now you need to have a in the tree. So basically some of the students are saying that a must be on the left only. Okay, since it is having the frequency 5 which is lesser than 6, so a must be on the left. See, there is no convention like this. I mean, you have to add at the same level, but it doesn't mean that a has to be on the left or right. This left is possible and definitely right is also possible. No one is stopping you to have a on the right also. Okay, right is also possible, left is possible and right is also possible. Some of the students are saying that if a is having the lesser frequency, then a has to be on the left, which is wrong. I mean, it is never, nowhere in any standard resource it is mentioned. Okay, see, the Hoffman idea is saying that if you are having the highest frequency, okay, let's suppose 7 8 these frequency, if this is the highest frequency, then I should be, it is about the length of the code. We should be assigning very less number of bits for that. If it is having more frequency, you can assign more number of bits. That's the simple idea. Left right is not the idea of the Hoffman. Okay, don't make it by your assumption. So basically this question I have taken from Berkeley University, and this diagram also I have taken from Berkeley University. Obviously this is the correct diagram. Okay, the a can be on the left also. I'm not saying it cannot be on the right. A cannot be on the left. A can be on the left, can be on the right. This left right is, there is no convention about it. Okay, so basically this is perfectly valid tree. Even see, after seeing the comments, I have placed one note in the answer that after the solution, many people commented that a should be on the left side. However, there is no standard rule that mandates the particular symbol must be on the left or right. Okay, left right placement does not matter. All that matters, the highest frequency character is assigned to the minimum code length. Interestingly, the exact question and the solution are taken from the Berkeley University. On page 4 of the official solution, you can also see the similar remark. So basically, here on the Berkeley University also, the link I have given here. Okay, I've taken this whole solution from the Berkeley University. At that place also, they have put this as a comment. There are many possible solutions trees. One is shown above, but one way to combine nodes at every step, but only one way to combine nodes at every step. Thus, any correct solution can be derived from the tree above by switching any nodes left and right subtree. So basically you can switch left and right subtrees. Okay, there is no convention about left and right. So how many of you have this misconception that A should be on the left? Now I think this is clear and there is no misconception, right? By the way, how many of you had this misconception earlier that A should be on the left or something like this? Because many of the student has commented here, okay, that this diagram is wrong. No, this is perfectly valid diagram. Now let's see this question. What they are saying, that consider circular doubly linked list shown in the figure. The variable sentinel is a pointer to the head. Head is also actually called sentinel. Okay, so some people, I mean, we generally use head as a keyboard, but some of the university also has the sentinel. Okay, which is same as head. So basically, this is pointing to the head, and then they are saying each node has okay. This is fine. Now, currently the previous pointer of the node containing 4 points to the node 3. Okay, but we want to change so that it points to 1. So basically, they are saying the currently it is pointing to 3 as shown using the solid arrow, but we want to change it to 1. Okay, this is what we want, right? This is what we want. Now they are saying that which of the following will do it. So you see here that this sentinel, I think previous. Okay, previous. So basically, we want to refer to sentinel previous, right? So sentinel previous should now be you can say sentinel next, right? Should now be sentinel next. So that's the only thing that we have to do. Sentinel previous should now be sentinel next. Very easy, right? It was a very easy question, but yes, this diagram was very good. I mean, it is looking very good diagram. It was easy doubly linked list question, and in GATE also many times they ask these kind of easy questions. So that's why we are basically in AIMT. It is AIMT doesn't mean that every question will be tough. Okay, so some questions will be easy as they are in GATE. Some questions are tough because in GATE also some questions will be tough. Okay. Now let's see this question. What they're saying in the heap shown below. So there is a one heap which is shown here. A parent node is less than the value of child when inserting a node to the heap. An element is added at the very end. So basically, you want to add some element here. If the element is less than the parent node, the parent and child exchange with each other. If element 7 is added to the heap at the position marked by star, what element will end up at position A? Okay, if you are adding 7 here, then which element will move to the 7 this A? So since it is a min heap, so 7 and 25 will get exchanged. Okay. So here you will be having 25 and then 25 and then you will be having 7 here. And since it is min heap, so 7 and 11 will get exchanged. Okay, so 11 will come here and 7 will go here. Since it is min heap, so 7 and 9 will get exchanged. So 7 will go here, 9 will come here. Okay. So ultimately at position A, 11 will be there. Okay, so B is the correct answer. Understood? By the way, one thing you notice here in the heap, whenever you're inserting, this path only get impacted. Okay. I mean, you do not impact any other path, only this path get impacted. In heap, this always the case. And one way to visualize it, like, I mean, one of the way, let me just tell you to visualize that where will this 7 come? Okay. So suppose you want to insert 7. Now if I just ask you directly, let's suppose, okay, where will the 7 come? Okay, I mean, ultimately the 7 might bubble up in the further nodes. So one thing is for sure that this path will only get impacted, right? I mean, no other thing will get impacted, only this path. Is this clear to everyone? Now, where will the 7 go? You just see that 7 is 7. I mean, you can treat it as sort. It will always be sorted, right? In the sorted, where will the 7 will come? Obviously, 7 will be here, right? So you can just treat it like that. Everything will get sifted down, and 7 will be here. Okay. I mean, you can just see that. Okay, this must be the sorted. It has to be sorted, and 7 will be at the correct position of the sorted array. Okay, so 9 will come here, 11 will come here, and 25 will come here. Everything else will just go one below down. Okay, this is one of the way to visualize. Even in one of the gate PYQ, there was one gate PYQ related to heap, and then they use the word called binary search. Okay, they use binary search word. They are saying that suppose you want to insert, let's suppose 7, then we are doing the binary search on this to find out the position of the 7. Yes, we can do the binary search here, right? Why? Because it is sorted. So we can do the binary search to find out the position of the 7. Okay. In one of the gate PYQ, they use this term. Gate PYQ. They use this term. It was a heap PYQ, and they use a binary search term. Even though you do not know about anything about the binary search about this concept, then also it was solvable. Okay, that question was solvable. But the thing here is that I don't think that anyone has hardly noticed this binary search word here. Okay, and why we can do the binary search? Why? Because only this path get impacted, so we can just treat this path as a sorted path, and then we can know the position of 7 using the binary search also. Okay, so there was one gate PYQ, heap PYQ, and they have used the binary search word. So you can just check about that PYQ on the Google. You just write three word: heap, gate PYQ, gate overflow, and then binary search. Okay, it must come something like that. If you write, okay, gate overflow, then it might come. Okay. Now let's see this question. They are saying that which of the following input showcase will not produce a binary search tree. So basically, if you notice here in the option D, I think option D is the correct answer here. Yeah. So between 6 and 7, 6 cannot come first, right? 6 cannot come first, because the moment 6 is coming, 6 will be here, and then if 7 is coming, 7 will be the right of 6. So between 6 and 7, 6 can never be coming first. So that's why D can never produce this tree. So D is the correct answer here. Okay. Now let's see this question. Here they are saying if all the eigenvalues of matrix are same, then what is the value of x? Right? If all the eigenvalues are same, then you can say that let's suppose lambda is the eigenvalue, the lambda plus lambda, which is 3 lambda, is a trace which is 6. So lambda is 2. Okay. If all the eigenvalues are same, then lambda is 2. Now, now you can find out the determinant of this matrix also. Okay. If you find out the determinant, then it will be 3 into 2 plus 1 into minus 2 6. Okay, 2x. So determinant will be 6 minus 2x, which is basically lambda cube, because the determinant is product of eigenvalues, which is lambda cube. So basically it will be 8. So from here you can find out x is minus 1. Okay, so D is the correct answer here. Yeah, now let's see this question, what they are saying. Let A be m cross n matrix of n real entries. Choose a correct statement of rank n. So rank n means that you are having all the columns are linearly independent. Okay, so you have n linearly independent columns, right? So let's suppose every column is in R5. It could be in anything, and you have three linearly independent columns, right? You have three linearly independent columns. Then would you be having solution for NEB? No, right? No, because in R5, it is possible that you will be having only for specific B's, okay, which are basically linear combination of these three columns. So this is no. Ax equal to 0 does not have a solution. No, obviously x equal to 0 has a trivial solution, which is x equal to 0. It always has the trivial solution, which is x equal to 0, right? If Ax equal to b has a solution, then it is unique. Yes, it has to be unique. So that's why this is true. Why? Because whenever the columns are linearly independent, okay. One thing you might know, but let me just tell you one thing, that let's suppose I'm representing a vector, okay, v, using some vectors. Let's suppose u1, u2, u3. Suppose this u1, u2, u3 are linearly independent. Okay. Suppose u1, u2, u3 are linearly independent. In that case, can you tell me? In that case, can you tell me number of ways to write or to express V as linear combination of U1, U2, U3, as linear combination of U1, U2, U3. Can you tell me? This is always one. Okay, always one. If U1, U2, U3 are linearly independent, then you can write V as exactly one way as the combination of U1, U2, U3. In other hand, if they are linearly dependent, then there are always infinite ways. Okay, if they're linearly dependent, then there are always infinite ways. If they're linearly independent, then there is always one way. Okay, so if they're linearly independent, and if you have the solution, then it must be unique. There is always one way to represent that whatever is this B as combination of, let's suppose these columns are C1, C2, C3 or whatever, right? So using these three columns you can represent V, if it is possible, then exactly in one way, because C1, C2, C3 are linearly independent. If these columns are linearly independent, in that case they linearly dependent, in that case there are infinitely many solutions. If the solution exists, okay, then there will be infinitely many solutions. So C is the correct answer, but let's just see D also. In D, they are saying y transpose A equal to 0 for some non-zero y, where y transpose denotes the transpose of, okay. So basically they are saying that y transpose A could be 0 for some non-zero y. So y transpose A actually means A equal to 0 means that if A is basically, let's suppose it is C1, C2 like this, right? C3. If this is A and y transpose is this, then it will be y transpose C1 must be 0. If the whole thing is 0, then y transpose C1 should be 0, y transpose C2 should be 0. I mean, y transpose A 0 means y transpose C1 should be 0, y transpose C2 should be 0, like this. What does this mean? That y is basically perpendicular to, y is perpendicular to all C1, C2, Cn. Is this possible? If it is also, see, my columns are in R5, right? Then by dimension wise, by has to be in R5. Is it possible that these are the linearly independent? Okay, and in R5, let's suppose I have, basically they are saying rank is n, right? So just a second, y transpose A equal to 0 for some non-zero y, where by transpose denotes the transpose. Okay, yeah, so basically, since the rank is n, if the rank is n, it means if we have n columns, then all of them must be linearly independent, right? Now, can there be one more y which is linearly independent of this? I mean, which is perpendicular to all this? It is not possible. Why? Because since rank is fixed, okay, since rank is fixed, let's suppose rank is 3. I mean, in this case, let's suppose rank of A is 3, which is basically number of linearly independent columns, okay. Let's suppose all the columns which are 3, which are basically n is 3 here, okay. So suppose rank is 3, I mean rank is n, which means 3, okay. So in this case, can there will be one more vector which is linearly independent of C1, C2, C3? It is not possible. If C1, C2, C3 are by themselves, they are linearly independent, then y cannot be a perpendicular to them, right? Because this will violate the condition that C1, C2, C3 are linearly independent. Okay. So so if you already have three linearly independent columns, right, then you cannot have one more linearly independent, I mean one more vector which is perpendicular to them, which means which are linearly independent of C1, C2, C3. Okay, because in the space of Rn you can have at most n linearly independent. So that's why this is false. Okay, y must be a zero vector in that case. Now let's see this question. So in this question, they are saying that a fair coin is you have a fair coin and biased coin. Okay, biased coin lands with the head with the probability 3/4. So you can choose a fair coin or you can choose a biased coin. Okay, to start with, one coin is picked uniformly random, which means with 1/2 probability you are choosing fair coin, with 1/2 probability you are choosing biased coin. If you are choosing fair coin, it could be head and tail. If you are choosing biased coin, it could be head and tail. Here, the probability of head is 1/2. Okay. In case of fair coin, the probability of head is 1/2. In case of biased coin, the probability of head is 3/4. So that's why it is 1 by 4. Now they are asking what is the total probability of head. Okay, what is the probability of head? So you can just add both of these paths, which is 1 by 2 into 1 by 2 plus 1 by 2 into 3 by 4. Okay, so it is 1 by 4 plus 3 by 8, which is 2 by 8 and 5 by 8, right? So 5 by 8 should be the correct answer, which is C. Okay. Yeah. Now let's see this question. This was a little, unconventional question in the sense that generally Gate has, I think, only asked one or two questions from token bucket or leaky bucket. But yes, there has been, I mean, questions from Gate, but and they can ask anytime. I mean, they can ask these type of questions anytime. So let me tell you what this leaky bucket is. Okay. See, let's suppose you are host. Okay, this is your PC. Okay, you are host, and you are basically sending some data to network. Okay, this is network. Now one thing is that you don't want to, let's suppose, okay, suppose you don't want to send the data at the irregular fashion, or you want to control the way in which you are sending the data to the network. For example, this is your application layer. Okay, some application. This can give, let's suppose, for 1 minute, it is, let's suppose, giving you 50 MB of the data, and for next 5 minutes it is not giving you anything. Okay, in that case you don't want to send one, I mean, you don't want to congest the network in the sense that you don't want to send 50 MB immediately for this 1 minute, and for 5 minutes you don't want to set ideal. Basically the thing is that in total 6 minutes, let's suppose in 1 minute the application layer is sending 60 MB of data. Okay, in 5 minutes it is sending 0 MB of data in next 5 minutes. Okay, suppose, just I'm saying you for example. So in total 6 minutes, how much application layer is sending? 60 MB, right? I mean, in first 1 minute 60 MB, and next 5 minutes 0 MB. So in total 6 minutes 60 MB. So what you can do, that you can by yourself, I mean, application layer can send by any speed. You can maintain some speed. For example, you can say that I will be sending, okay, here I will be sending in the regular fashion. In 1 minute. Okay, so I will be sending, let's suppose, 10 MB per minute, something like this. In 1 minute I'm sending just 10 MB, which means you are also sending, it is possible that you are also sending in 6 minutes how much, 60 MB to the network, but not immediately. Okay, not in the first minute. I mean, you are regulating. This is called traffic shaping. Okay, so you are shaping the traffic. This is called shaping protocol. Traffic shaping protocol are leaky bucket and token bucket. Okay, leaky bucket. This question is related to leaky bucket. It is just aptitude kind of question. I will just let you know how to solve this question. It is just aptitude. Okay, kind of question, but it was a good question. Let's just see that how to solve this question. So basically, they are saying that you have a leaky bucket of size 20 packets. Okay, so I will just tell you that what does this mean. Let me just go to the next page. So they are saying that there is a leaky bucket of size 20 packets. Okay, which means you can hold at most 20 packets at a time. Okay, so the leaky bucket is 20 packet size. Now initially, okay, from this 0 to 4 interval, okay, in initial 4 seconds, you are getting packets with the 6 packets per second. Okay, and a leaky bucket is basically leaking the packets with 5 packets per second. Okay, so basically you are having a leaky bucket. This is the host. The leaky bucket is inside the host only. Okay, leaky bucket is inside the host only, which means this is the leaky bucket, and here through the C, this is the application layer. Let me just tell you how things happens. This is application layer, which can send data at any rate. Okay, and there's a leaky bucket which will shape the traffic. and both are within the host only. Okay, leaky bucket is not outside the host. This is within your computer. Okay, within the host only. Both are within the host. Application layer is within the host. Leaky bucket is also within the host. Okay, so this is your host. But before sending the network, you are sending it to leaky bucket, and leaky bucket is trafficking the shaping or shaping that traffic. Okay, which means leaky bucket, they are saying it can hold at most 20 packets at a time. Okay, I mean the maximum capacity of the leaky bucket is 20 seconds, and it is sending, the sending rate is also given. Okay, it is sending at the fixed rate, which is like 5 packets per second. Okay, it is sending at the rate of 5 packets per second. Is this fine to everyone? I mean, it is given in the question that it is sending with the rate of 5 packets per second. Now, the question is asking that if this is the scenario, then finally, how many packets are getting dropped? Okay, I mean, how many packets you are getting dropped, and total how much time it will take to transfer whatever you are not dropping. Okay, whatever you are not dropping, how much time you will take to transfer that. See, for the initial 4 seconds, you are giving me 6 packets per second rate. Okay, you are giving me 6 packets per second rate. I am sending with the 5 packets per second. So which means 1 packet per second I am storing with me, right? So after 4 seconds, how many packets leaky bucket will be having? After first 4 seconds, how many packets leaky bucket will be having? Can you tell me? So just a second. See what I'm saying here. Okay. What I'm saying here is that you are sending 6 packets per second to me. I am sending 5 packets per second. So in every second, I'm basically saving. I'm keeping 1 packet with me. In 4 seconds, I will be keeping four packets with me. Okay. So after these 4 seconds, leaky bucket will be basically storing 4 packets, right? Okay. And every other packet it has already sent. Okay. So I just have 4 packets with me currently, which is fine. Now, in the next 3 seconds, the incoming rate is too high, 10 packets per second. Since I can send with 5 packets per second only, so 5 packets per second I'm storing with me. So 4 packets are already there, and 5 packets per second for the next 3 seconds, which means 15 more packets I'm storing with me. So total, I just have now 19 packets with me. Okay, at the end of the 7 seconds, I have 19 packets with me. Is this okay to everyone? Now for next 2 seconds, okay, you are sending with the rate of 8 packets per second for the next 2 seconds, which means since I can send only by 5 packets per second, that is why uh, so 3 into, I mean basically 3 into 2, 6 packets I will not be able to send, right? And 6 packets I will try to store. Okay, but I have 19 with me already. Okay, 6 I will try to store, but since it is total 25, I will not be storing, total 25. I will have to drop, I have to drop 5 packets. Okay, I have to drop 5 packets. Is this fine to everyone? Right, I need to drop 5 packets. Okay, so I have already dropped 5 packets, and my leaky bucket is now full. Now, in the next 3 seconds, what is happening? Now they are saying now the incoming rate is 4 packets per second. But since I can send with the 5 packets per second, so I will be, so next 3 minutes, 3 seconds, I will be basically from 20. I will send three from here. I will sending three from here. So I will be having 17 packets in my leaky bucket now. 17 packets will remain in my leaky bucket. Okay, after this, because 4 is the incoming rate and I can send with the 5. So that's why 17 packets I will be having with my leaky bucket. Is this understood to everyone? Let me know. Now there is no incoming after that. So I can do what? I can say that now I only have to send these 17 packets. So how much time you will be taking to send these 17 packets? With the 5 packets per second. How much time? So 17 divided by 5. Okay. Which is basically, I think, okay, 3.4 seconds. Right. 3.4 seconds I will be taking. So basically, I will be taking 3.4 seconds more after this timeline. Okay, after this timeline, I will be spending 3.4 seconds more. Okay, more. So 5 packets I have dropped, and I will be taking after this 12 3.4 seconds more, which means total I will be taking 12 plus 3.4, which means 15.4 seconds I will be taking total, and I will drop 5 packets. Okay, so 15.4 seconds I will be taking total, and I will drop 5 packets. So that's why D is the correct answer. Okay. So is this question understood to everyone? Let me know. Great. It was a good question. Okay, it was a good question. Now let's see this question. This is also a good question. This was related to go back end and SR protocol. So here they are saying go back end is basically having the window size 3 and SR is having the window size of 4. Okay. Packet indexing start from 0. On the AB link, the packet 1 and 4 is lost in their first transmission. So basically you are having A, B and then C. Okay. This is A, this is B, and then this is C. By the way, this question I think is one of the unique question. And before that, I don't think we had some question which was related to both go backend and SR. I mean, in just one question, one link is using go backend, another link is using SR. I don't think we had such kind of things. But yeah, that's fine. So basically, they are saying that packet zero here the window size is 3 and here the window size is 4. Okay, here the window size is I think 4. Okay, here the window is 3. Right now, what they are saying is that you are sending the packets, right? And packet 1 and packet 4 are lost in the first transmission from A to B. So basically, you will be sending 3 packets, by the way. Let me just send 3 packets quickly. 0, 1, 2, right? And this packet 1 is actually lost. Since it is go back N, it will wait for its timer, right? And then it will send 1 again, 2, and probably 3, right? That's fine. Okay, then they will get acknowledged, which is fine. And then it will send, see, it will send 4 also, right? Now it will send 4 and 5 and 6. And since 4 timer getting expire, the 4 timer is getting expire, so that's why 4 5 6 it will send again. Okay, after the timeout it will send 4 5 6 again. Is this fine to everyone? This is the timeline from side A. Okay, we will see timeline at B. I mean the packets how the B is treating. But is the A part okay to everyone? I mean it is easy only. We are just saying that this packet and this packet are getting lost. Okay, these 2 packets are getting lost. This is the only thing that we are trying to emphasize. So if these 2 packets are getting lost, then you will send these again, right? 4 5 6 you will send again. Sorry, this 4 is I think this, which is okay, 4 was this. So basically 4 5 6 are getting lost. Okay. Now at B, what will happen? B will get this 0 and we will send this 0 immediately. But since B has not got 1, and obviously it will discard everything since it is go back n. Okay, this I mean the receiving window is go back n, it will discard everything. And it will basically wait. Okay, now the 1 is getting received, so it will send 1. Now the 2 is getting received, in order it will send 2, it will send 3. Now 4 has not received, so it will basically not accept this 5 and 6. 5 and 6 will be rejected because the receiving window is basically go backend, and go backend just have one window size. So 5 and 6 will be rejected. Now the moment it is again getting the 4, okay, it will send now 4, 5 and 6. Okay, but at side of B also there is some interesting thing which is happening. They are saying that this whenever B is finally receiving packet 4 from A, it forwards to C for the first time, and packet 4 arrives C in the error, so C does not acknowledge it. So you can assume that packet 4 from here is getting lost. Okay, or basically I mean not lost, basically C does not acknowledge it. But yes, packet 5 and 6 has received. Package 5 A received, 6 is received, right? Is this fine to everyone? Now, what they are saying, what packets B must have sent to C after the first transmission of packet 4 and before the timeout caused by packet 4. So basically, they are saying that now this B will send the packet 4 again. Okay. So after the packet lost and before the timeout, what are the packets that you are sending? 5 and 6, right? You are sending 5 and 6. So 5 and 6 are the correct answer. It was just a question to have this, go back and SR both, but it was easy question only. Okay. It was easy question only. So 5, 6 are the correct answers here. Okay. This is the diagram that we have. Okay. Now let's just move to the next question. So by the way, for this question, the answer is 5 and 6, which means C is the correct answer. Now let's move to the next question. So in this question, they are saying that you are having two routers in between, router 1 and router 2. And using these two routers, you are sending some packet. The packet size is 3000 bytes. Okay. And the MTU of the router is 1500, 800, and 1000. Okay. So they're saying IP header is 20 bytes. So if you have the first packet out of this 3000, if you remove this 20 bytes of the IP header, then you will be having how much here? 3000 minus 20, right? I mean, you will be having this much, okay, which is I think 2980, right? 2980 bytes you will be having. Now you have to send those 2980 bytes to this MTU of 1500. MTU 1500 means effectively, apart from the IP header, you can send 1480 bytes of data, right? This much bytes of data. Understood? So now they are saying that how many fragmentation will be there at the router one. I mean, from the sender, how many fragmentation will be there, and then at the router one. And actually, at the router two, there won't be any fragmentation because earlier MT was the lesser. So let's solve this question. It was easy question only. So you can divide. So one of the student has answered. So we can take from that. Okay, I think this is TCP message size. Okay, this is TCP message size. So you don't have to remove this 20 from here. Okay, because the TCP message size is 3000. Okay, which is basically including the TCP header, not the IP header. Okay, so 3000 you have to send through this MTU, and since the MTU is 1500, so 1480 effectively you can send, right? So you have to divide this 3000 into 1480, 1480, and what will the remaining one? The third packet will be of 40. Okay, 40. So you will be dividing like this: 1480, 1480, 40. So this is the first packet. This is the second packet. This is the third packet. Now third packet is very less, so it will not be divided further. But the first and second packet will be divided into, this is 780, right? I mean, effectively you can send 780 bytes of data apart from the IP header, basically, right? So it will be divided into 780, 780. But 780 is not a multiple of 8. I think the nearest multiple is 776. Okay. So 776, 776, and the remaining will be here. So let me just check how much is remaining. Okay, this is 776 and 704 is remaining. Okay. So 776 and 704 is remaining. Similarly, it will be divided into 776 and 704. Okay. And this 40 is as it is. So total 5 packets you will be having. Right. Now, if you want to find out the fragmentation offset, then how you will find out? For the first packet, it is 0. For the second, it will be 776 divided by 8. Right. So you can do the calculation basically. These are the first 3 packets, and it will be divided into 776, 704, 776, 704, and 40, right? For this, the fragmentation offset is 0. Okay, but now if you divide this 704 by 8, then you will be getting 97. Okay, sorry, 776 divided by 8, then you will be getting 97. Is this fine to everyone? Okay, so 796 divided by 8. Sorry, 776 divided by 8. This will be 97, right? So divided by 8, you will be getting this much fragment offset, and then you can keep on calculating. So basically, this combinedly divided by 8, you will be getting 185, and so on. Okay. So these are the fragment offset, and finally B is the correct answer here. Okay. So here B is the correct answer. Now let's just move to the next question. Yeah, let's see this question. So basically, this question was actually got printed, little bit. One of the data got printed, I think, wrong. So that's why in the exam, this question was wrong, but I have corrected it. Corrected the data. Solution was based on the correct data only, but somehow the question got misprinted. Okay. Anyway, so let's just solve this question. This was very nice question, I can say. One of the unique question of the banker's algorithm. Okay. So what they're saying, consider a system with three resources ABC. So the as usual current allocation maximum available, these are given. Assume that resources are allocated according to the banker's algorithm. Any resources granted to T1 remain allocated until T1 finishes the execution and system must remain in the safe state. So they are saying what could be the maximum number of resources. Let's suppose XYZ is the maximum number of additional copies of ABC that you can give to T1 such that there is no risk of deadlock. Then what are those ABC? So basically, what are those XYZ? I mean, since it is NAT, so I have converted like 100x plus 10 by plus Z, something like this. Okay, I have converted like this. I mean, so that any three number XYZ can be represented like XYZ. Okay, that's why I have converted like this. So let's solve this question. See, available at 211. Now they are saying what is the maximum that T1 can request. Okay. So available at 211, maximum need of the T1, which is given here, is 494. Okay. Maximum T1 can request 494, obviously. Uh, and currently it has 213. And need, basically, you can find out the need by the subtracting this. Okay. Then need is this, right? So they're asking maximum T1 can request such that there is no deadlock. Okay. That's what they're asking. Now you see, obviously available at 211, maximum it can request 211. I mean, this is very obvious. I mean, if it is requesting more than 211, then there's a deadlock. I mean, we don't want any deadlock, so two should be less than 211, right? Now, if it is requesting 211, in that case, the current allocation, obviously it will be incremented by 211, so that's fine. But the need, you can say the need. Okay, so if you are requesting 211, let's suppose XYZ are 211. Okay, 211. In that case, what will the need of this need will be 070, right? And available will be actually 0. That's the problem here. Okay, available will be 0. Okay, I mean 000, right? Available will be 0. So but the thing is that no other need is 0. Okay, if you have 211, if you directly request 211, then this need will become 20020, right? Sorry, this need is 410. I mean, there won't be change in obviously any of this need. So this need is 070, and basically there is no zero need, right? There is no zero need, but available is 0. So that's why 211 is the hilarious. I mean, you cannot give 211 to T1. Okay, because there will be a deadlock, because there is no available and everyone is requiring something, right? Is this fine to everyone? So 211 should not be given. Now what is the next thing that we should try? See, whatever you give, okay, whatever you give, available should be such that it should satisfy one of the need, right? So basically, we give, whatever we give to T1, available should be such that at least one of the need. मतलब, like I'm not saying this will work. I mean, this should be the bare minimum criteria. Okay, at least one of the needs should be satisfied from remaining available. Okay, one of the needs should be satisfied from the remaining available. What is the minimum need here? Minimum need is 100, right? Minimum need is 100. So whatever you give, so basically if you subtract 100 here, it will be 111, right? Okay, so you can give at most 111, right? I mean, if you give 111, then the remaining available will be 100. At least you can satisfy T3, right? At least you can satisfy T3. Is this fine to everyone? So basically you can say let's just try giving 111. Okay, so let's just see what if what if I'm giving 111. I mean, this is just a try. Okay. See, I earlier gave 211, it got failed. Okay. I mean, 211 is not a nice idea because after 211, available was becoming zero. Okay. So 211 I tried, but after that, available was becoming zero. So it got failed. Not a nice idea. Now let's just try with 111. Okay. Which means from this 2, I'm basically decrementing to 1. Why I'm trying with 111? At least T3 need will be satisfied. Okay. So now available will be, since the T3 needs are satisfying, so available is basically 100. That's fine. Okay. Now you can say the available is 100. Okay. Now since T3 needs are getting satisfied, so that is the reason that whatever T3 is currently holding, okay, 543, it will get released. So available will now become how much? It will become 3, 4, 6, 4, 3, right? Available will be now 6, 4, 3. Okay, this is available, and T3 has got finished. Okay, T3 got finished. Now with this 6, 4, 3, okay, can you satisfy anything else? Anything else future need? So this need is actually lesser because 111 I have already given. So you can subtract 111 if you want. It will be 170. Okay, it will be 170. With this 643, obviously I cannot satisfy this. Yes, I think I can satisfy this, right? 643. Yes, I can satisfy T2 now. Okay, so if I satisfy T2, then T2 will also release. T2 will also release, right? So what T2 will release? T2 will release whatever it is currently holding, which is 1, 2, 3. Now the available will become 667, 766, right? This is now new available, and T2 will also be finished. But because of this 6766, okay, because of the 6, you cannot satisfy T1 because, sorry, T1 required 7, and T2 also, T4 also required 7. So basically now there is a deadlock. Okay, now the deadlock is coming. Basically, even with 111, you can satisfy T2, T3, but you cannot satisfy T1 because 170, T1 required 170, and you have only 6 resources of B. I mean, B resources are in the scarcity. Okay, we should not allocate B resources. We should keep the B resources with us. Okay, we should keep the B resources with us. That is the thing. Which means that we should not assign 111. Let's just try with 101. Okay, I'm not assigning B resources. This one resource is crucial, seems to be crucial, right? This one resource is playing a good role, so I'm not assigning this. Let's just assign 101. Okay, so basically, just a second. Let's just x y z be 101. Okay, let's just check with 101 if everything is working fine or not. Okay, if you assign 101, now the need will be here since you have assigned 101 already, so current will get incremented and need will actually get decremented. 101 if you assign, it will be 18180, right? It will be 180. And with this 101, obviously you can first satisfy T3. So available will become, if you are satisfying, see, 101 if you are giving, so available after subtraction, available will be 0 1 1, right? This is the available. But now after this T3, the available will be incrementing because of this T3. Okay, 543. So this is 3 5 6 653. Now it has become. So T3 is now completed. With this 653, can you satisfy anything? I think you can definitely satisfy this T2. So let's just satisfy this T2 and then let's just add this 1 2 3 also because of this T2, right? Okay. Now this is 6 7 7 7 7 6. Now with the 7 7 6, can you satisfy something? Yes, you can satisfy T4, right? Because it is requiring 7 here and you have the 7 here. So you can satisfy this T4 also. So let's just add for the T4 also. T4 is basically 2 1 2. Okay. So it is 8 8 9 9 8 8, and you can definitely satisfy the remaining T1. So basically this 101 is the maximum that you can that T1 can request for, or in other words that banker's algorithm can grant. So XYZ maximum could be 101, which means 100x plus 10y plus z is 101. Okay. So this was a nice question, and 101 is the correct answer here. Understood. Now let's just move to the next question. Let's see this question. This question was related to synchronization. So let's just see that how to solve this question. So basically, you are having two processes, and if you write the code like this, I mean the separate code, then there will be a turn. I mean there will be the entry section, critical section, and the exit section. Now let's just check. Can there will be the mutual exclusion? Can there be the deadlock? Something like this, right? So let's just first check the mutual exclusion. Will there be the mutual exclusion, or it will not be having the mutual exclusion? Let's just first check this. See, I want that both of the processes should be entering, okay, in the critical section. If I want to violate the mutual exclusion, then I want that both of the processes should be entering into the critical section, isn't it? Right. So basically, let's just check if it is possible. See, I have to violate this to enter into the critical section, and I have to violate this also. Okay, and I have to make sure that both of them are in here in the critical section. I can do it. I can do it. Okay. Uh, if I'm basically setting one of the variable here, and and then not setting one of the other. Okay. I'm basically in these type of problems where you are setting the multiple variables. Okay. In those problems, basically what you need to do, you should be preempting here after just setting one of the variable. Okay. After just setting one of the variable, just see if you preempt, which means let's suppose turn is 1. Now you preempt. Okay. Now you preempt from here. Now you execute this whole. Now turn is 1, which means now you execute this whole. Turn will be 0. Interested of 1 is 1. Interested of 0. Actually, both of the interested through may in the initial both are the 0, so it is basically false, right? Interested of 0 is 1. This is false. So that is why you will say that this is false, right? I mean, this will be equal, which is okay. So this is false. So that's why you are able to enter into the critical section. Are you getting my point? Basically, interested of 0 and interested of 1. Initially, they are false. Both are 0, right? Now, turn will be 0. Interested of 1 will be 1, which is fine. But interested of 0 is still 0. Okay, interest of 0 is still 0. That is why you are basically able to say that this is false, and now I am in the critical section. Okay, now I'm in the critical section. This process, P1 is in the critical section. What about P0? Can P not go and come again? I mean, sorry, can P not go inside the critical section? Let's just check. Interested will be 1, okay, which is fine. Yes, this is true, but since the turn is now 0, okay, since turn is now 0, so that's why it is also able to enter into the critical section. So P note can also enter. P note can also enter. P1 can enter and P note can also enter. Okay. So both processes can enter. Is this fine to everyone? So that's why mutual exclusion is violated. Okay. See, in these kind of problems, you always do one thing. You always, preempt after setting one of the variable. Then you will see if there is a problem or not. Okay. Now in the Peterson algorithm, if you remember, in the Peterson algorithm, actually, instead of turn, I was calling it favor variable, which is fine. So basically, I had something like this. I was actually having this exchanged. Okay, I was writing interested above, and then I was writing this turn below. See, the question is saying the same thing. Consider the following modified version of the Peterson algorithm, where the turn variable is a shared variable and both entering in the critical section. Okay, so basically, this is a modified version of the Peterson algorithm, and then they are saying the above differs from the original Peterson because the turn is assigned before interested. Because the turn is assigned before interested. Okay, I mean, if you flip it, it will be Peterson's. But if you don't flip it, it is the modified version, and this modified version is actually not working. Okay. Because mutual exclusion is not satisfied. What about other things? The algorithm makes sure mutual exclusion, this is false, violates the mutual exclusion for some interleavings. Yes, this is true, right? What about C and D? Which means will it cause deadlock? Will it be starvation free and so on? Okay, let's just check it. These are actually easy in this case. Okay, see, generally mutual exclusion is easy, but in this particular question, deadlock and starvation checking is comparatively easier than mutual exclusion. Let's just check. So for the deadlock, basically, you just see that both of them must be stuck in this while loop, then only deadlock can come. Can both of them must be stuck? No. Because of this turn variable, because either it is 0 or it is 1, right? I mean, it cannot be 0 and 1 at the same time. So both of them cannot stuck in this while loop. So deadlock is not possible. It is very straightforward to check deadlock here. So you can say deadlock is not possible here, right? Deadlock is not possible because either turn will be 0 or turn will be 1. I mean, turn cannot be this and this cannot be true at the same time. So both the processes cannot be stuck at the same time. So that's why deadlock is not possible. What about starvation? Starvation means for the starvation you have to do one thing. You just ask one of the process. Let's suppose P1 P1 to basically stuck in this loop, which means P1 is here, and let's suppose P note is here. Okay, let me just do one thing. Let me go to the next page. Let me copy this. See here also, here also we have written it is deadlock free, right? And starvation means that process is bound to enter in the critical section, but is infinitely postponed. I mean, it is keep on waiting, and other process is making some progress, right? In this algorithm, every process turn equal to other before waiting. This ensures that if one process is waiting, the next assignment of the turn, the the process will eventually favor the waiting process. See, let me just tell you what does this mean. Let's suppose one of the process is waiting here. Process P2 is here, and process P1 is here. In that case, can you tell me the variable values? Turn will be how much? Interested of 0 will be how much? And interested of 1 will be how much? Okay. So if you are stuck here, so turn must be 0, right? Interested of 0, if you're here, stuck here, interested of 0 must be 1. And since you are here, right? So interested of 1 also be 1, because interested of 1 is only set by this. Okay. So it must be 1. Okay. So this is the current condition, right? And this process is here. Now if it is going out, okay, if it is going out, interested of 0, it is setting to be 0. Now if it is coming in, now let's just suppose it is trying to come in, interested, the turn it will set to be 1, Interest of 0, it will again set to be 1, which is fine. Now can it go again in interest of 1 is 1? Yes, this is true, and turn is 1, this is also true. So the p1 will not be, sorry, p naught will not be able to enter again. P naught will not be able to enter again, right? So that is why p naught cannot go out and cannot come again while this is keep on waiting. So p naught will not be able to do it. What about okay, let's just call it p1. What about p1? Now since instance at 0 is 1, that is fine, but since the turn is now 1, so this is false, so p1 can enter now. Okay, p1 will be able to enter. So starvation is not there. Understood? So it was a nice question, to be honest. It was a nice question. Now let's solve this question. There are only few questions remaining. Let me tell you that. Okay, just a second, sorry. So basically, yeah, the C programming question, and I think there are two, three C programming question, and then matrix multiplication question, and one, two questions are only remaining. Okay, so let's just solve these questions. Okay, three, four questions are remaining. So basically, here in this question, it was related to C programming. This question is saying that you are in this main function. Okay, I mean the execution will start from the main function only. Let me do one thing. Let me just go here. So they are saying that you are basically having A, which is one struct, which is fine, and then you are having B. Now you are initializing a pointer. I mean, sorry, not initializing. You are just declaring a pointer. Tell me about this. Suppose you do this, okay? Int star p and star p equal to five. Is this okay? Is this valid? Tell me. Is this valid? Is this valid? See, P has not been initialized to any address. I mean, before, in between that, you should be writing something like P equal to address of A or something like that, right? If you're not writing, if you're directly dereferencing, in that case, it will be undefined behavior. You do not know. I mean, at the runtime, you do not know that what is this P garbage value. It might lead to the undefined behavior. Okay. So similarly, the things are happening here, that you cannot, just because you are declaring a pointer b, you cannot ask that b of x. I mean, b is not pointing to any valid struct, right? B is not pointing to any valid struct. So you cannot talk about x and y here. Okay. So basically, this is called dangling pointer issue. Okay. This is called dangling pointer. This is called dangling. This pointer is called dangling pointer. Right. Similarly, this pointer is called dangling pointer. This is a dangling pointer issue. Okay. Now you are allocating some memory, which is fine, and then immediately after allocating, you are writing c equal to something. I mean, you are not storing this, okay, this c somewhere. I mean, the memory that you are basically, now c is pointing to some memory. Now immediately you are saying that, okay, let's not point to this, let's just point to some this add, whatever this add is returning. So basically, you're losing the memory immediately. It is as good as saying, something like this. See here, suppose you have int star p equal to malloc. Let's suppose this is int a, int star p equal to malloc. Okay, int star something, right? So let's suppose after this line, okay, I write p equal to address of a. I mean, I'm immediately losing whatever this P was pointing to. So P is pointing to some heap memory, okay, some heap memory. And immediately I'm asking, okay, let's not point to this heap memory, let's just point to my local variable A or anything else, basically, doesn't matter, okay. So obviously, this is a memory leak issue, okay. Here, I should be storing whatever P was pointing earlier. So this is memory leak issue. So this is called memory leak, right? Memory leak. Sorry, this should be int size of int. So this is called memory leak. Is this fine to everyone? Even if you write just p equal to malloc, okay, malloc, let's suppose 4 bytes, and immediately let's suppose you write p equal to malloc, let's suppose 8 bytes, then also this is memory leak. This is also memory leak because you are immediately losing whatever p was pointing to. So from the main function itself, you can say it was a dangling pointer issue, and because you're losing the memory by c, so that's why it is a memory leak issue. Okay, this is a memory leak issue also. Understood? So dangling pointer, memory leak, both are there. Okay. So in the options, the program has dangling pointer issue. Yes. The program has memory leak issue. Yes. Now let's just see the other options, which are free B and free C. What they are doing. Okay. So see here, B is actually not even initialized, and I'm just doing free B. It doesn't make any sense, right? So it is undefined behavior. For free B, it is undefined behavior. B is not pointing to any malloc related memory. Okay. B must be pointing to heap memory, then only free B is completely defined, otherwise it is undefined. Okay. So it is also undefined. Now, what about this free C? Now let's just see the C. If C is pointing to some malloc memory, or in other words some heap memory, then only this free C is valid, otherwise this is not valid. Okay. Let's just see what this C is pointing to. So if you see the complete program, this C is pointing to some local variable res. I mean, because I'm returning the local variable address, which is actually not recommended. I mean, this local variable is getting vanished after this function call, so it is not recommended to return the local variable address. Okay. Not recommended to return local variable address. Understood? So that is why you will say that if you're returning res address, then C is basically pointing to the local variable, and it is not pointing, first of all, it is not pointing to the heap memory. So free C is also undefined. Okay. So you can say that free works only on the heap memory. Only on only on heap memory. Okay. So free B and free C both are undefined actually. So that's why correctly deallocates. So that's why these are wrong. Okay. So A and B are the correct answer. Okay. For this question, A and B are the correct answer. Now let's solve this question. So in this question, they are saying that there is some A which is gate 2026, and then uh, n is set to be 9. Basically, n is the length of this particular string, which is 9. Okay. And then you want this function to change it to something like this, right? Something like this. Now they are saying that what should be the parameter of this str function? Okay, what should be the parameter of this function? This is the question. So see here that what this is doing, this function is doing. If you notice, it is exchanging. See, n is the length, but n minus one is the final, you can say, index, right? Because indexing always start from 0. So basically, this is GATE, okay, gate space and 2026. So let me write GATE 2026. So indexing always start from 0. So it is 0, then this is 1, this is 2, this is 3, and then let me use some other color. 0, 1, 2, 3. Then this is 4, this is 5, this is 6, this is 7, this is 8, right? Okay. So indexing will be from 0 to 8, or in other words, 0 to n minus 1. This is n minus 1, right? Now I'm passing n, which is okay, but indexing should be till n minus 1. I hope that is fine to everyone. Okay. It is not a confusion here. Now what this function is doing, it is first exchanging this g and then this 6. Okay. It is just exchanging these two. It is exchanging g and 6. So it is swapping g and 6. So basically you will say that g and 6 will get swapped. So here you will be having 6, here you will be having g. Okay. Now this is swapped. Now what should be the next thing that you should be doing? Tell me. See, interestingly, you should be starting from here, right? I mean, you should be starting from here and going till here, right? So starting from here means it should be, instead of passing a, you should be passing a plus 1. Okay, starting from here and going till here means instead of swapping n minus 1, you should be swapping n minus 2. I mean, actually whatever you write here, just you are basically having swapping n minus 1, so you must be sending n minus 1 so that you swap n minus 2. See, if you are passing n, then you are swapping n minus 1, right? And you want to swap n minus 2. So that is why you pass n minus 1. So this should be, the arguments of this function. Because here increment, but here decrement. Okay. So earlier you are passing n, but now pass n minus 1. Increment here, but decrement here. Okay. So every time you are basically reducing the size of the array by 2. I mean minus 2. Basically one from the left and one from the right. Okay. There are questions where basically they keep on swapping, and then I mean there could be the variation where if this is not there, okay, if this is not there, something like this, okay, I mean there could be the variation where they don't change the starting index. And if you keep on swapping, actually if you don't stop by n by 2, okay, I mean if you don't stop till middle, then if you go till the end, then there are two times swap and finally you get the same string. Okay, so just be careful. Okay, here you won't be getting the same string, but it might be possible if you keep on swapping like this. Okay, keep on swapping, and if you do it n times, then there might be possible in some variation where you are getting the exact same string instead of the reverse string. Okay, but here I'm basically saying that let me decrement from the left, or maybe like this, I mean increment from the left or decrement from the right, something like this. So I'm basically passing this. Okay, I'm reducing the size minus 2 minus 2 minus 2 at every iteration. Okay, so a plus 1 and n minus 1 is the answer, right? So I think B is the correct answer. A plus 1 means address of a1, address of a1. Okay, so B seems to be the correct answer. Sorry, C is the answer. Yeah. C is the answer or B is the answer? Okay, C is the answer. Let me just check. Each call swap the first and last character. If I'm passing n, then you are basically swapping a0 and n a minus 1, right? So let's do one thing. Let's just dry run this algorithm one more time. Let me just take this on the next page, or maybe here itself. So basically, what we are doing, each call swap first and the last character, then the function should process only the remaining middle part. So basically, first call, if it is gate 2026, first call will swap G and 6, which is fine. Then we need to swap A and 2, right? We need to swap A and 2. So to swap A and 2, basically we need to swap, this is n minus 1, right? N minus 1. We need to swap n minus 2 and a of 0, I mean, if I'm passing the pointer to A, then n minus 1, A plus 1. If I'm passing n minus 2, then it will automatically swap n minus 3, right? Just a second. Let me just check the answer. So it is question number 60, right? C is the only answer here. A plus 1 and n minus 2 we are doing. Each will swap the first and last character, which is fine. So if I'm passing n, then I'm swapping n minus 1. Now I want to swap basically a and 2, right? So initially I'm swapping this a and 8. So g and 6 are getting swapped. Okay, okay. Uh, so basically the n is the length of the array, right? So n is 9. Yes, this was very tricky. Okay, I also got confused here. So n is 9, but now the n is 7, right? But now the n is 7. So since n is 7, okay, n has already decremented 1. I mean n is now 7 because now the length is 7. So basically you will be doing n minus 2, right? Because now the length is already 7, right? Now the length is 7, so you will be doing n minus 2 so that you come here. Because see here, because we are that's very tricky part. We are basically incrementing this a, right? A plus 1. Now a is now pointing to, okay, your base is now pointing here, right? Your base is now pointing here. Now from here you cannot go n minus 2, oh sorry, n minus 1. I mean from here, basically what is happening, see, what you are doing, at every iteration you are swapping a0, and whatever n you are passing, with that n you are swapping a n minus 1, right? I mean this is what you are doing at every iteration. Is this okay to everyone? So we are swapping this g and n minus 1. Okay, great. So n minus 1 means this a n minus 1 means this a is important actually. Because a is getting changed, so that's why this n minus 1 will play a crucial role here. See what is happening, that this n minus 1 is with respect to this a, right? Now in the next iteration, since I'm changing this a to this a, right, I'm changing this a here. Okay, so basically in the next iteration, you always see something like this, that you are basically decrementing the length, right? I mean you're decrementing the length already by 1. So now you cannot go in the next iteration. You are not measuring from here. Okay, you are not measuring from here. This is the important point. If you are measuring from here, then this is n minus 2, I agree, right? But since you are measuring from here, now you have to measure from here. So this position is n minus 3 actually. N minus 3 actually. Okay. Because you are measuring from here. If you are measuring from here, then this position is n minus 2, right? And this is n minus 1. This position is n minus 1. This position is n minus 1. This position is n minus 2 if you are measuring from here. But since now you are measuring from here, that's why this position will be itself n minus 3. I mean not n minus 2 actually. Earlier if you're measuring from here, it is n minus 2, but now it is n minus 3. Okay. So if you want to swap a0 and a n minus 3, okay, this is what you want to swap basically, right? You want to swap this. If you want to swap with a n minus 3, then you have to pass n minus 2. Okay. You have to pass n minus 2. Is this okay to everyone? Okay. The catch here is that now you are measuring from here. This is very important catch. Okay. Or if you want, you can basically just have other recursive calls. Let's suppose this function name is str fun, right? So initially you are calling with a comma n, right? A comma n. So let's suppose the base address is 1000 and n is anyway 9, right? So you're calling with 1000 comma 9. Okay. So let's suppose this base address is 1000. This is 1000. This is 1004. This is 1008. Okay. Similarly, since this is just one away, this is four. So 2, 3, 4, 5, 6, 7, 8 away. So you can have 1032. This is 1032. This is 1028, and so on. Okay. So basically, you are having this function, and this function is getting initially it is getting passed with 1000 comma 9. Now what it is doing? It is swapping. Basically, it is doing two things. It is first swapping from this, okay, 1000. Basically you can say whatever you are passing from this a of 0, you are swapping a of 0 comma this a of 8. Basically you're swapping these two, I mean first and last. Okay, first and last you are swapping, which is fine. You are swapping first and last. Okay, which is great. Now suppose you are passing, now you are having a recursive call str fun c. Now you are doing a plus 1, which means 1004 comma. Now this element you want to swap, right? This element 2. So what you should be passing here? What you should be passing? In other words, you can think like this, that you are always passing the length of the array. Okay, length of array. You are passing length of the array. Now you want to decrement the length by 2. Okay, from one from here, one from here. You want to decrement the length by 2. So that's why you should be now passing. Okay, you should be now passing a, which is the starting point, which is like a plus 1 comma length of the array. Okay, now the length of the array starting from this, now the length of the array is basically 7 only. Okay, earlier you had the 9 characters in total, you can count it. Now including from this, from what is the length of this array? What is the length of this array? From here to here, what is the length? It is 7, right? 7 length. So comma 7, or in other words 9 n minus 2. Okay. Now basically you are passing n minus 2. Why? Because you are passing the length of the array, length of the whatever length you want to consider. Okay. If you are basically pass n minus 3, then it will swap this 0. Okay, 0 with a, something like this, right? You have to pass n minus 2 because now this is the desired length of the array. Okay. This is my new length of array. It is clear to everyone. So that is why C is the correct answer. Okay. It was very tricky question. Okay. So I can say it is very nice question. Okay. Now let's see this question. This was easy one only. So basically here you first be knowing what is the cost of matrix multiplication. Let's suppose you are multiplying A and B matrices. This is having, let's suppose, P into Q cost. Okay. Suppose P into Q cost. This is having, suppose, Q into R cost. Q into R cost. Then A into B will be having PQR cost, right? I mean P into Q dimension, Q into R dimension. Then A into B will be having PQR dimension, right? Now suppose you are having B and C. Okay, B is having Q into R dimension, C is having R into S dimension, then B into C will be taking QRS time, right? Now suppose you want to multiply ABC, where AB you are doing first. Suppose this is P into Q dimension, this is Q into R dimension, this is R into S dimension. In that case, AB will be taking how much? PQR, and the dimension of AB will be PR, right? P into R. So ABC will be taking this, further multiplication will be taking this PR dimension will be there. So PRS, right? So total it will be taking PQR plus PRS. Okay. This is how matrix multiplication work. Understood? Okay. So let's just see this option. Computing ABC and ABC both take the same time. If it is P, yeah, every dimension is same, then yes, it will take the same time, right? It won't matter. Now let's see this B option, which was more nicer option, I can say. So they are saying if 1 upon Q plus 1 upon S is less than 1 upon P plus 1 upon R, then ABC takes less time than ABC. So let's just first compute this. ABC time is this. let's first compute the other time, which is A and then BC. Okay. So BC will take QRS, okay, QRS time plus the dimension of this will be Q into S. So it will PQS. So it will take PQS, right? So total time it will take this. Now they are saying that ABC, what is the condition? Okay, let's just check what is the condition. Let's suppose that this ABC takes less. Okay, so A and then AB and then C. Okay, let's suppose this is taking less. So which means what should be the condition? The first is taking less. For first to take less, you should be writing PQR plus PRS should be QRS plus PQS, something like this. Okay. In that case, if you know things are like this, I mean three or four variables, you just divide by PQRS both side. Okay, divide by PQRS both side. So if you divide by PQRS both side, then what you will be getting? You will be getting here P 1 upon S plus 1 upon Q is not there, so 1 upon Q should be lesser than 1 upon P plus 1 upon R, right? 1 upon S plus 1 upon Q should be lesser than 1 upon P plus 1. Yes. So basically, you can say this is correct. Okay. ABC takes PRQ plus PRS time. Yes, we have seen this. This is also correct. ABC takes lesser than ABC if P plus Q is greater than R plus S. I think there is no such condition. Okay. I mean, nothing like this. I mean, this is true, but this is false. Okay. So ABC are true. Correct answers are ABC. Okay. Now let's see this question. This question was nice question, and this was related to insertion sort, and not related to much of the merge sort, but yeah, merge sort time complexity is needed to solve this question. Okay, they have given the time complexity also, so I think it was basically related to insertion sort only. So they are saying that each element is at most k elements away from its correct position. Okay, what does this mean? It means that if you take, okay, if you take, let's suppose, any element, ith element, then then it can be at most here, I mean on its left, on, I mean in the sorted array, it can shifted at most k positions here or at most k positions here. I mean there won't be more than k positions shift for this I. Okay, not more than k positions away. So how does the insertion sort work? Insertion sort basically says that let me take, every element, and it basically places it to the correct position, right? If it is not, k positions away from its sorted position, in that case you will say that you will be, for every element you will be taking k time, because it is not more than k positions away from its correct position. So for every element you will be taking at most k time, right? So insertion sort in this particular array will take nk, order of nk or theta of nk, you can say, right? This much time taken by insertion sort. This much time insertion sort will take. Now they are saying that any function is said to be asymptotically faster than any other function if it is following a small o relation, which means if it is strictly lesser. So they are saying what is the maximum asymptotic value of k for the given from the given options for which the insertion sort is asymptotically better than the merge sort. Okay, which means this nk should be strictly lesser than n log n. Okay, because this is a small o relation. I mean I'm not writing c into something, but I hope you understood, right? So from here you can say that k must be strictly lesser than, asymptotically I'm talking about, strictly lesser than log n, which means from the given option, which option is strictly lesser than log n? C, right? C. So C is the correct answer. Okay. Now let's check this question. This was easy question actually. Now they are saying that there are distinct values where the height, where the tree has height 10. Okay. The tree has a property that is in order and post order traversal are same. What is the maximum number of nodes that can be present in such a tree? So they are saying in order. In order means left, root, and right. Okay. In order. And pre-order means root, left, and right. Okay. This is pre-order. This is in order. This is pre-order. Okay. Now they are saying they both are same. How can they both be same? If they both are same, then L must not be there. Okay. Left must not be there because then only they both will look same. So basically it should be the skewed tree. Okay, so it should be the skewed tree where left is not there, right? So uh, so you can see the tree must be something like this. Okay, I mean left must not be there, right? So what will be the maximum number of nodes? If the tree is having the height 10, then you can say the maximum number of nodes will be 11. I mean this is the height 1, so maximum number of nodes are 2, then like this, right? So the tree will be having 11 nodes. Okay, so basically this left in order and pre-order, post-order, what they are saying. Okay, they're saying post-order, which is fine. In case of post-order, let me write. Okay, this should be left, right, and root. Left, right, and root. Post-order. For post-order, if they both has to be same, then in that case, you can see if right is not there. Okay, if right is not there, then they will be same. Left and root, left and root. Okay, then you want right to be not there. Okay, so maybe you want the tree to look something like this. Okay, you want the tree to look something like this. One, two, three, like this, right? And so on. So the number of nodes will be 11. Okay, you don't want right to be there, so that left and root will maintain the consistency. Right part must be empty. Okay. So here in this question, one of the student is saying that sir, option A is less than also less than log n, but they are saying maximum. Okay, maximum, what could be the maximum asymptotic? Okay, so maximum is basically whatever is the less than log n. So log n divided by this some function which is log n is obviously lesser than log n. I mean this is obviously greater than one. This is not less than one. Okay, if it is less than one, then this is the answer. This is greater than one. For example, if this is like this, okay, log n divided by n, then obviously this is the answer. Okay. Now let's see this question. This was easy question. So here they are saying that insert is basically inserting at the front and delete is deleting at the last. Okay. And now if you have something like this, empty is basically just checking whether the queue is empty or not. Now you're deleting. Okay. You're deleting from the front, which means initially the queue is 1, 2, 3, 4, 5. You're deleting from the front and then you're putting the same element to the last. Okay. So deleting from here, you're putting it to the last. And then you are doing it initially k is given to be I think 3. You are doing it basically I mean you are doing it again recursively, you are doing it, but you have to do it basically with the k value 2, which means you will do it two more time. So which means one more time if you do it, then see initially if you do it, then it will be 1, 2, 3, 4, 5. If you do it one time, then one will get from here, from it will come here. If you do it one more time, then like this. If you do it one more time, then it will be like this, right? So 4 will be at the front and then 5, then 1, 2, 3. So B is the correct answer. 4 is at the front and then 5 and 1, 2, 3. Okay. It is just doing the same thing again and again recursively. It was easy question only, which was like free 2 marks. Okay. See, people say that Go classes test series, Go classes tests are very hard, but I think only few questions are hard, which are expected from Gate also. Okay, so it was like free 2 marks. Let's just see this now. This was also easy question which was related to MBT. So mean value theorem says that if there are like two, two values, let's suppose A and B, and there is some function. Let me take the simple function. Then there must be some tangent at C. okay, which is parallel to this line AB. Okay, I mean this slope which is f dash c should be equal to fb minus fa divided by b minus a. Okay, this is mean value theorem. Okay, this is basically mean value theorem. Now if you put all the values, then here they are saying that f dash x is less than or equal to 4. Okay, given that f3 is 15. Okay, so basically they're applying the mean value theorem between 1 and 3. So f3 is given at 15, and f they are asking the minimum possible value of f1. So this is given to be 15 minus f1 upon divided by 2 less than or equal to 4 is also given. Like they are saying that f dash is less than or equal to 4 in this range. Okay, for this range f dash x is less than or equal to 4. So if this is also given, and this is a standard question actually, so f1 is greater than or equal to 7. So you can say the minimum value will be 7. Okay, minimum has to be 7 to satisfy the mean value theorem. So 7 is the correct answer. Okay, so that is all. I mean, though these are all the questions I wanted to discuss, and I think there are like a few comments. Let me just take the comment. So one of the student was asking that, sir, if the test series was what right now, will I be able to solve previous papers? Yes, you will be able to solve all the test. Okay, if you take it right now, then definitely you will be able to solve all the tests. Okay, so the answer is yes. Great. So that's all for the discussion. Let's just meet in some other session. So thank you everyone. If you have understood everything, just let me know in the comments. Okay, we will appreciate if you commented. Just let us know how was your experience with the AIMT, and let us know in the comments. Thanks. Okay.